In this video, I will show you how to find the Maclaurin series for a given function using the definition. And to do this task, we're going to organize our work in a table. Here we're going to list the steps. We're going to find the nth derivative. We're going to evaluate the nth derivative at 0. Then we're going to compute the nth term coefficient by using this formula. And then we're going to write the actual nth term. So when n is 0, we're just dealing with the function itself. And the function itself evaluated at 0 is 0. So the nth term, in this case it's 0, will be simply 0 divided by 0 factorial, which is 0. So the free coefficient is 0. Next term, let's take the derivative. So it's going to be 1 over 1 plus 2x times 2 by the chain rule. Evaluating this at 0 will give me 2. And finding the coefficient will give me 2 divided by 1 factorial, which is 2. So the term itself is 2x. Next step, differentiate again. So we have negative 1 over 1 plus 2x times 2 again. So now evaluating this at 0 gives me negative 4. And finding the second coefficient, or a2, will be negative 4 over 2 factorial, which is negative 2. So the term is negative 2x squared. Next term, differentiate again. So here I made a mistake. We take the derivative, so negative 1, I forgot to increase the power by 1. So now when I take derivative again, I'm going to have negative 1 times negative 2 over 1 plus 2x cubed times 2 times 2 times 2. So evaluating this at 0 gives me actually 16. And now finding a3 will be 16 over 3 factorial, which is 8/3. So the term is 8/3 x cubed. Next, we have negative 1, negative 2, negative 3. The power in the denominator goes up by 1. I'm just using the power rule, and multiply by another 2. So evaluating this at 0 gives me negative 96. And finding a4, it's negative 96 over 4 factorial, which is negative 4. So the term is negative 4x to the power 4. So the first 4 terms of the Maclaurin series are, so I'm going to write this here, it's 2x minus 2x squared plus 8/3 x cubed minus 4x to the power 4. So we completed the first task. Now to find the general formula for the nth term, we have to try to figure out the pattern here. So for the kth term, the kth derivative will be what? So what's the pattern here? It seems like we're going to have a negative 1, negative 2, negative 3, and so on until negative k minus 1. It seems to be the pattern in the numerator, divided by 1 plus 2x to the power k times 2 to the power k. So evaluating that at 0 just basically gets rid of the denominator. So I'm still going to have negative 1 to the power k minus 1 factorial times 2 to the power k. So that's the value of the kth derivative at 0. And now finding a k will give me, like, basically taking this term, 2 to the k, and dividing it by k factorial, as that's the formula. And now simplifying this a bit further gives me this result. So we got the formula. So the general term of Maclaurin series for this function is that, and therefore the series itself can be written like this.